Let's work on practice 11.12, finding a directional derivative using this gradient. So instead of going through that limit process every time, you can use the fact that the directional derivative is the gradient vector projected onto the correct direction. It's very nice. Here we have an electromagnetic field has energy measured in joules, and it's a function of three-dimensional space. So at a given point in space, the strength of the field is given to me by that B function. All right, I want to find the rate of change in energy at the point 210 as I travel towards the point 500. All right, so as we move from the first point to the second point, what's the derivative of the B function, the electromagnetic field energy, with respect to our movement? So let's move everything over to a fresh sheet of paper. The magnetic field strength is a function of three dimensions. So every point in three dimensions has a different field strength. It's given to us by x cubed plus 1/2 xy minus 2z. All right, what's our initial point? 2, 1, 0, and we're traveling towards the direction of 5, 0, 0. This directional vector is then 5 minus 2, 0 minus 1, and 0 minus 0. Right, so that's the vector that points me from my initial point to my terminal point. Now, I need to find a unit vector in this direction, right? Because I don't want this vector to have length, because that's going to change my problem. I want it to just point me in the right direction. So the unit vector is going to be this vector v divided by its norm, which if you go through this, we get 3 over root 10 minus 1 over root 10 and 0. Okay, now the B function is going to have a directional derivative in that direction u at the point 2, 1, 0, which is the gradient of the B function at the point 2, 1, 0, dotted with the unit vector that gives me my direction of travel. Right, this is so nice. I can get any directional derivative I want to by taking my gradient vector, which is the vector of partial derivatives, and then projecting it onto the right direction. All right, let's go through this. The gradient vector of the electromagnetic strength field at the point 210, we get a 25 over 2, a 1, and a minus 2. Right, so I skipped some steps there. To find the gradient vector, you need to find your partial derivatives and then evaluate your partial derivatives at that point 210. You should come up with 12.5, 1, and minus 2. Right, so that's the slope of this function, and then we're going to project that onto the right direction. 3 over root 10 minus 1 over root 10 and 0. This gives me 75 over 2 root 10 minus 1 over root 10, or 73 over 2 root 10. And this is going to be measured in, so our B, the strength of the magnetic field, electromagnetic field, was measured in joules. So this will be joules per meter. So as we move from this point towards that point, our electromagnetic strength grows at a rate of 73 divided by 2 root 10 joules per meter.